So just like in human nutrition, nutrients are crucial. And so we're going to balance a nutrient profile for an animal a little bit differently than we would humans. Obviously, we're not having to worry about things like pizza or ice cream. But the same kind of nutrient profiles that we talk about for healthy human nutrition, you're going to see a lot of those terms come up this week as we go through this content. And so that's really where we're going to start this week is what is a nutrient? What are they? What do they look like in certain feeds that we give livestock? And then we'll kind of start talking about how do we use those nutrients on a health and a kind of ration basis. Now, anytime we give animals feed or we're producing a ration with feedstuffs, they are going to contain nutrients. And nutrients are going to be anything that kind of sustain those metabolic processes in the body. So everything from DNA copying, cellular respiration, mitochondria producing energy for the body, any of those kinds of really, really small biological processes we saw in the cells a few weeks ago. A nutrient is also defined as the end product of digestion. So when we break down feeds and they get to their kind of smallest unit the body can absorb, that's really what we call a nutrient. And that's going to be anything that allows an animal to grow and maintain themselves over time. Like we see in human nutrition, if you've taken any type of health class, whether that was in junior high, high school, college, these terms are probably pretty familiar to you if you're really conscientious about, working out or what type of micro or macro nutrients you're getting into your body. You may have seen these before. So livestock, it's the same situation. There's going to be 6 types of nutrients. We call them 6 classes of nutrients, and that's going to be water, protein, carbs, vitamins, fats, and minerals. Now, these 6 classes of nutrients are going to break down into subcategories. So you'll notice water does not have a subcategory. You either get water or you don't. The only thing we have to be careful of is if we have some type of toxic water or water has been polluted, then we'll have some issues. But otherwise, usually water is just water. Now, when we get into carbohydrates, carbohydrates break down into sugar, starches, and fibers. And then when we get into protein, protein breaks down into essential and non-essential proteins, and we'll talk about kind of some of those examples as we move forward this week. Fats can come into saturated and unsaturated forms. So if you've ever seen, the liquid versus solid, butter versus olive oil, we're going to see the same principles apply to livestock and how we kind of utilize feeds based on what chemical profile they might have. Now, minerals, you're going to see macro and micro minerals, and vitamins are going to come into the fat-soluble and water-soluble categories. You will need to know the nutrients and their subcategories. You will have questions about that on a quiz. Before we get into kind of nutrient functions, I want to be very clear that there will be quite a few nutrient categories, so carbs, fats, and proteins that you're seeing at the bottom of this slide that actually help the body do work or give the body energy. Energy is defined as the ability to do work. It is not a nutrient, so sometimes it gets a little confusing. Energy is not a nutrient. It's actually the product of nutrients getting broken down and then absorbed into the bloodstream. So very important. Again, energy is not a nutrient. It is a byproduct of nutrients being broken down by the body through digestion and then absorption into the bloodstream and then as it goes to its correct tissues or cellular levels. So water is kind of one of those things that we think about on a nutrition level that really it's not highlighted, right? A lot of times we'll hear human nutritionists say, drink your water, and then, humans drink soda and coffee and all the other good things. But one of the things that's really important to understand is that any of our livestock species, 70% of their body is actually water. So it's very important that we see water provided both as drinking, so they need to have access to clean, fresh water at all times. So we're thinking, no ice in the winter, no algae in the summer. They need to be able to have access to it at any time, day or night. And when we see animals, removed from water, don't have access to water, we tend to see, health issues and ultimately death. Water has huge properties in the body, so it's going to do everything from transporting nutrients in the bloodstream to helping maintain body temp. We're going to see it actually be a huge component of milk production. So 87% of milk produced by most livestock species is going to be about 87% water. So very important that this is taken care of in our livestock. So carbohydrates that are consumed by animals are going to be plant-based. They're usually a product of photosynthesis of some type. We're going to see them come in both simple and complex form. However, the sugar, starch, kind of fiber or cellulose formats of carbohydrates we're going to see in animals are not quite the same as what we think of as carbs in humans. This ingredient or this nutrient needs to be about 80% of the diets in livestock. It's really a huge portion of the energy source for an animal, as well as kind of that bulk or fiber portion for a lot of our livestock. It's really important for digestive health. So carbohydrates are huge, and you're going to see those used very, very often on the farm. So there are lots of types of carbohydrates that we're going to feed in livestock production. More often than not, you're going to see us feed starches and fibers. Every now and then, again, you'll see a simpler form of carbohydrates, so sugar, and it might be something like molasses in a diet, but more often than not, it's just starches and fibers. So in starches, you're going to see everything from cereal grains, so think things like oats and barley and wheat and corn. We may feed tubers and roots, so anything from, maybe some byproduct wastes off some of the food production in the human culture. We might feed them off a pasture that has leftover corn stalks and leftover ears of corn, or a turnip field. So there's lots of ways that we can feed them starches. They're very, very easy for the body to break down. Very simple digestive systems do really well with this. So think things like pigs and chickens, those monogastric animals. Fibers tend to be really, really high in cellulose. Much harder to digest, so we tend to see these consumed by horses, cows, sheep, and goats. So think the ruminants and the hindgut fermenters. This is things like hay and silage and forage and pastures. And you're going to need those special microbes inside some of those fermentation vats to help break down that fiber. Now, protein is one of the most expensive ingredients we have in livestock diets. And part of this is because you can't actually store protein in the body, so it has to be constantly supplied. It is a source of energy, but it's very expensive, so we don't often feed protein for energy. We just feed protein for protein in the body. And the reason for that is that there's what we call essential and non-essential forms of protein. This comes down to the amino acids that different livestock or different animals need. And so essential proteins mean that if they're not provided in the diet, that animal cannot get access to it anywhere else. They can't produce it. Their body can't synthesize it. And so if it's not given in the diet, we start to see a breakdown in biological processes because it doesn't have the ingredients it needs to function properly. Now, non-essential proteins means that the animals, can eat things and it can synthesize it from something it might have eaten, and so it's no big deal. And so we have to be very, very careful of this, especially in animals like cats and pigs. They have some specific amino acids, such as taurine and lysine, that if we do not give them those specific ones in their diet, they actually have major health issues, and then ultimately it leads to death. So protein is the building block of the body. So it has everything to do with biological functions, so think muscles, basic cellular processes, DNA, the immune system. It's an energy source. It's a building block for trait expression. So if the body's not getting access to protein, it's a huge concern. And the other thing I want you to kind of note here, I'm not worried about you knowing the equation at the bottom or being able to replicate it, but what I want you to understand is that we actually don't measure protein because we can actually calculate the amount of protein in something. We actually measure protein based on the nitrogen content. So there's actually a formula. If I take the amount of nitrogen that we can calculate in a feed and I multiply it by a conversion factor, so 6.25, I can actually calculate out this value we call crude protein, meaning that I'm not actually really measuring it. It's just kind of a crude estimation of the protein in something. And so crude protein is the value we use to estimate protein content in feeds for livestock. So you'll see that word come up throughout this lecture, crude protein, and that's really what that means and where that came from. So fats can come from plant or animal sources. You may see them in liquid or solid form, so unsaturated versus saturated. This is actually an extraordinarily dense energy source for animals, and it's actually more energy dense than carbohydrates and actually will help with weight gain as well. So fats are actually the biggest energy source or biggest energy feed that we can give to an animal. However, we have to be very careful because sometimes the palatability of fats isn't very great, so we tend to feed them in a smaller amount even though they're very energy dense. So very important to understand that when we add those to a diet, we can actually up energy and up weight gain without them feeling like they're eating a bunch of bulk, because fats are very, thin, very easily spread, kind of if you think oils and butters. It's very easy to put them on something without having an increase in the bulk of the ration and still seeing that energy and that fat allow weight gain or basic cellular processes. So fats are very, very important. We do use them sparingly just because of palatability issues, but they're great. So minerals are classified as inorganic, meaning they do not contain any carbon, hydrogen, oxygen, or nitrogen. And we're going to see two classifications, macro and micro. Sometimes you'll hear micro minerals referred to as trace minerals. Macro minerals means we provide them to an animal in large amounts. Micro means they're provided in small amounts. And then just make sure that you can give me an example of both of those, as well as, a mineral that might be in that category. So macro could be calcium, micro could be cobalt or iron. Just pick the one that kind of makes the most sense to you. But make sure that you can tell me difference between those two and an actual example. And minerals are huge. So they have everything to do with hormones, the nervous system, pH balance, structure, transport. They do a lot of different things in the body. And so just like within humans, we need to supplement minerals and making sure that we're getting the right balance of those, because we can see lots of health conditions develop just because of an imbalance in mineral level in an animal. So vitamins are categorized as organic nutrients, meaning that they contain carbon, hydrogen, oxygen, and nitrogen in their chemical level. And we really only need these in small amounts when we're supplementing in livestock. There are two categories, so fat soluble and water soluble. Fat soluble means that when those are consumed by an animal, they're stored in the fat in the body. And water soluble are actually peed out. So that's why, just like in humans, when you drink an energy drink and you've got greenish, bluish pee, you're actually peeing out any of that vitamin B that your body couldn't use. And so it's really, really hard for an animal to have toxic levels of a water soluble vitamin, whereas sometimes we can see toxic levels of fat soluble vitamins, so we have to be a little careful with those. Now, fat soluble, you're going to see those vitamins kind of do the same thing that we would see in humans, right? If I eat a bunch of carrots, there's a lot of vitamin A. It helps my vision. Things like regulating body functions, blood clotting, tissue maintenance, and then we're going to see B and C really have to do with enzymes and energy and metabolic regulation, or any of those kinds of processes that you'll see in the body kind of helping with energy and digestion and absorption and different things like that. So all of those classes of nutrients, the 6 that we just went through, are huge. When we see those incorrectly fed or balanced in an animal, we can see all sorts of different types of issues. And so it's really important to understand that just like you're seeing on this slide, if we don't have enough protein or the minerals or vitamins are not properly balanced, if we're seeing a decrease in carb and fat consumption, we're going to see problems. And just like with water, water has to be consumed as well. And so protein, you tend to see, something like growth and development issues, or you see, DNA problems. You're going to see decrease in cellular function. You're going to start seeing poor coat. You're going to see an animal not wanting to eat a lot. You might even see death, because protein just really has to do with so much of how the body works. And so you'll see animals just kind of start to waste away. Now, minerals and vitamins, you can see anything from, decrease in production, bone problems, respiratory issues, digestive problems, vision problems, blood issues. And then carbohydrates and fats, you're going to see things that really have more to do with energy. So they're going to see a loss of weight. Maybe they don't have good energy. They just don't look right. Maybe their coat's dull. They just look sick. And so these are just a couple quick examples for each one of those that we might see if an animal's not being fed properly.